lesson 5, so multiplication of rational expressions. A little bit of a short lesson today. So it says review of multiplication of rational numbers. So remember, multiplying fractions, it's nice because why is it easier? Because we don't need a what? Right, we don't have to have a common denominator. We just go bang, 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 right across. Multiply, multiply. And so it just makes it easier when you're multiplying fractions. So consider the factors of the numerators and denominator. If there are factors in common, then you can cancel. So this is just talking about if you recognize that they have stuff in common, you can reduce before you multiply. And all that does is it helps you not have to reduce later. Okay, so let's just talk about what they're saying right here. I'll show you. So let's look at, for example, let's look at A and B here. So this one simply is, so you can ask yourself, is 7 have anything in common with 5? No. And then 7, 10, 1, and 10, nothing's in common here. So this one's going to be simplified when I go straight across. 7 over 50. That's as simple as it gets. The reason is, well, 7's prime for 1, and then 2, you can see there's no factors that cancel. All right, I'm going to show you 2 ways to do the second one here, and I don't care which way you like. Okay? Like, you get to choose. Okay, so now this one, for B, there is a little bit more simplifying to do. So I'm going to do the simplifying way first. So 5 and 10 have what in common? 5. Yes, they go each other twice, but we can make this a 1 and this a 2. 5 over 10 is 1 over 2, right? And then 9 and 6 have what in common? 3, and then that's 2, right? 3 times 3 is 9. 3 times 2 is 6. So we just kind of reduce those by their common numbers. Why that helps us is because, look, what's 3 times 1? 3. 2 times 2? 4. That's the answer. It's fully simplified. Now let's say you don't like doing that, and that's what I was talking about, and Brett laughed. I don't care if you don't like doing that, that's great. The other way you do this, you're going to see why it's a little harder. 9 times 5 is 45. 10 times 6 is 60. Now you have to reduce that. Okay, this one you can see because of time, right? We're good with 15s. 3 over 4 is what that reduces to. So you can multiply first, then reduce, or reduce before you multiply it. It doesn't matter which one you go with. Okay, any questions on that? You can. Yeah, you can on that stuff. I would just say, like, I don't want us to be too calculator dependent on that kind of thing because that's kind of a number sense thing. So even the funny part is, and to get off track here for the video, but it comes to stuff like this. If you look at the curriculums, okay, there is a section that's called NS, and it's called number sense. And so if you're using your calculator for this, you're not looking at the number sense thing and understanding the patterns of the numbers, Parker. So can you? Yeah, you get the fraction on your calculator, but it might come back to bite you when it comes to variables or different things. So just long story short, you can, but don't fully rely on it would be my answer. Okay, so now we're going to deal with what we're doing for us now. Okay, so the thing that I like to do here is look at the variables first. The numbers is kind of the part that has to do a little bit more math work, but the variables is actually pretty simple. What I mean by that is that, okay, I have an x here and x here. Is there any x's in the bottom? So what's x times x? So we know we have an x squared on top. So my x's are done. Then just kind of mark your x's off. Okay, now look, I have a y here. Is there a y on the bottom? So that just cancels. Y cancels, y cancels. Y over y. Okay? And then we have a z squared and a z1. So there's 2 z's on top, there's 1 z on bottom. So what do we have? We cancel the one on bottom, but we have 1 on top left. Okay, so if you want to do that, I'm going to go with what you said. You said 36 over 4. That's fine, but we can simplify 36 over 4 to 9. It's okay. If it was 3, it'd be 12. If it was a 3, it'd be 12. You don't want that far off. Okay, 9x squared z. Or z, sorry. I gotta start saying z again. Yeah, sorry. Okay, all right, so then this one. Now they're going to try to look at that. That looks like a bunch of gibberish, to be honest, right? Just a bunch of letters, a bunch of stuff. Just go piece by piece. This is why I said at the start of this section, guys, factoring and organization is going to carry you. Okay, if you can do those 2 things, you're going to be great. Okay, so a squared, no other a up here, a cubed. So I have the 2 a's on top, 3 a's on bottom. So just 1 on bottom. So we can mark your a's off. Your a's are done. Okay, I have a b squared on top and a b, and then a b squared on bottom. So how many b's are on top? 3, and then how many's on bottom?
2.
So it means 1 on top. I'm done with my b's. I have 4 c's on top, C4, and how many c's on bottom? 2. So what do I have then? Where's the c's at? C squared on top. Okay, are we going too fast? Does anybody need any clarifications? What we're doing here. And then a d on bottom, there's no other d's, so we just keep the d on bottom. So our variables are done, a through d in this case. Now we got to look at the numbers. Now do you see how this one's going to get pretty ugly with the numbers? 5 times 35 and 14 times 40. So this is one where it might be easier to do the reducing. Do you see what I'm saying? 5 times 35 and 14 times 40, that's not going to be friendly numbers. But we do know, for example, 7 goes into these two, 2, 5, and 5 goes into these two, 1 and 8. So I'm going to get 5 over 16. See how this makes your numbers a little easier? Okay, but again, you can do like what Parker said. You can go 5 times 35, and you can go 14 times 40 and try to do the fraction method if you like. That's fine, but that's your simplified version there. Okay, all right. So now we're going to be looking at it where we have a little bit harder pieces. Okay, single variable rational expressions. So we have the method of multiplication of rational expressions similar to this method, describes multiplication of rational numbers. First step is usually to factor. So we want to factor so we can see if there's anything we can cancel. Now what I kind of explained to people in this, and they still, I don't know, maybe you can tell me what you think, but really, since it's already factored, they're all products, right? So essentially, guys, this thing's, that's the top, that's the bottom, right? They're all multiplied together. Just think about it pushed together, because they're going to be multiplied anyways. So what I'm saying is, since they're all pushed together, this and this cancel, because it's really all one thing. Yep, and so this would go, and right, and so it would be 2 over, 2 is all that's left, x minus 2 and x. So that's what it would be. Now it still says state the restrictions, so we still have to do that before we cancel. Yeah, Gavin, did I forget something?
No, never mind.
Okay.
I was going to say,
Oh, okay. So, yeah, don't distribute unless you can, Gavin, but it doesn't really help you in this case, yeah. So your non-permissibles, though, come from here still. 2, negative 3, 0, negative 1. Can't be 2, can't be negative 3, can't be 0, can't be negative 1. That comes from what makes the fraction or the factor 0, right? There's 4 factors there. Okay, any questions there? Okay, so you can kind of see this one. We need to factor a couple pieces because we don't have anything we can cancel right now. It doesn't mean we have to have something to cancel, but I do know that 4 goes into those two numbers, 7 goes into these two, and then that one, nothing happens. So if I simplify this one, I pull a 4 out, that gives me x plus 4. We like that because we have an x plus 4. If I pull a 7 out, that gives me 2x minus 1, and we like that because we have that over there. So you see how we factored, now we see the things we can cancel. Yeah, so let me rewrite it so we can see a little better. So the top left is going to be 4 times x plus 4. The bottom right is going to be 7 times 2x minus 1 times 2x minus 1 over x plus 4 squared. Before we cancel, let's do our non-permissibles real quick. Non-permissibles, we can't have, what's this one? 1 over 2, good. And this one, negative 4. Okay, so that's my non-permissibles. Now, you guys see the 2x minus 1, simple, that just cancels, right? Cancel, cancel. The x plus 4, though, what happens? Right, so there's 2 on the bottom, there's 1 on top, so that means there's going to be, this one's gone, and this one's changed to a 1. So, right, so 4 over 7 times x plus 4 is your simplified expression. Any questions? We're on the decline here. 2 more examples. No questions? All right. We're going to get a little uglier here. Is that what you're looking at, Lucas? Okay. So they're putting you out with a bang here. They got a couple trinomial ones coming. So like I said, the key is factor organization. So you need to factor all those pieces. So let's see what that is with factoring. So this guy right here, let's pull out a 2m squared. That's what they have in common, right? So that gives me m minus 2. The bottom, 3m, gives me m minus 3. What's the top factor 2 for the right side? Yep, minus 3 plus 2. And the bottom factors 2. Yep. Okay, now you can see the factoring is a huge piece, right? Because right now, to me, this is super simple now. Because everything's factored. We just got to worry about what we're crossing off. Okay, so that's why I said really Unit 2 is the backbone here. So let's do non-permissibles before we cancel. Non-permissibles are, what's this one? So, yep, so 0 for the first one, plus 3, plus 2, minus 2. So I got 4 non-permissibles. And now let's go ahead and cancel. So we are canceling. Are we good? Okay. So m squared over m, so the m cancels, knocks that one to a 1. Because there's 2 m's on top, there's 1 m on bottom, so we have 1 left on top. M minus 2, m minus 2, m minus 3, m minus 3, m plus 2, m plus 2. Everything went away except for 2m over 3. All right, one more. Any questions? All right, let's look at this last one. Gets a little bit messy, but we'll be all right. Okay, so let's just go ahead and just, right when I see all this stuff, I'm just like, all right, I need to factor it. So that's what I'm going to do first. So the top left, and I kind of like, when I'm doing my work too, I kind of have like a little section of factoring when I have to do work. Like I have to do work on this one, and I have to do work on this one. These two won't be too bad. Okay, but the first one we can factor pretty easily. What's the top left one? Okay, good. A plus 5, A plus 3. Now the second one, the reason it's a little tricky is because there's a 6 there, but they also all have a 3 in common, right? 6, 21, and 9. So I'm going to take a 3 out first, and that gives me 2a squared plus 7a plus 3. Now I'm going to factor that. No, we're not going to distribute because we just took that out, right? Oh, the 2 times 3? Yeah, that's AC, yep. 2 times 3, 6. 6 broken up into 7 is 6 and 1. So 2a squared plus 6a plus a plus 3, and then we group. That's our decomposition. Pull out a 2a. Yeah, just positive 1, but yeah. So this one, nothing comes out because they're positive, so it's just going to be a 1 to us. And so now over here, it's going to be 3 times 2a plus 1 and a plus 3. Okay. Now we're going to go to the top right. So the top right, you can pull out an a. And when you pull out the a, it gives you 1 minus 4a squared. Well, what's 1 minus 4a squared? Difference of squares. Yeah, it's a difference of squares. So it's going to be 1 plus 2a, 1 minus 2a. Because 1's a perfect square, 4's a perfect square, and then a squared, right? Difference of squares. Okay. Any questions? In the bottom right, we have to do some more decomp. So I'll do it down here in the bottom right. So we're going to go 2 times negative 5, I get negative 10. So like what Brett said, I'm distributing there, the a and the c. Factors of negative 10 that give me 9 is 10 and negative 1. So this one's going to be 2a squared plus 10a minus 5. We'll group. Pull the 2a out. Pull the negative 1 out. Okay. So this one's going to be 2a minus 1 and a plus 5. So now, like I said, that was the hard part, just a bunch of factoring. Okay, now we just got to go through, let's do our non-permissibles, and then we'll cancel. Our non-permissibles are what? Negative 3. Okay, good, we got 4. 1, 2, 3, 4 A's. All right, so what cancels? A plus 5, a plus 3. Close. Right, so let's talk about that one. So everything is close to canceling. So, right, so what I have is, it's a times 1 minus 2a. So you guys remember that rule, which is good. So that's close. There's the opposite. Okay, so you can pull the negative from the bottom, the negative from the top. It doesn't matter. And so if we pull a negative at the top, like Nolan said, that makes it negative a over 3, which is the simplified version, because then those will cancel. So what happens if you pull a negative out, that makes this negative, that positive. Now these are the same, and we can cancel. Okay, and that's it.